First, I will solve these two questions from the last day. Okay. This question, they mention that px cube plus qx square minus 5x plus 1 is divided by x square minus 1. So, this is our dividend and this is our divisor. Then they have mentioned that remainder is minus 3x plus 4. Then this is our remainder. Now, according to division algorithm, we can write our px cube plus qx square minus 5x plus 1 is equal to x square minus 1. That means divisor times quotient. That means capital Qx plus remainder. Now, already they have mentioned that our remainder is minus 3x plus 4. Then we can rewrite this as px cube plus qx square minus 5x plus 1 is equal to x square minus 1 times qx plus minus 3x plus 4. Okay. Now, they ask from us to find the values of p and q. Okay. Now, this is our divisor. Our divisor is x square minus 1. Okay. Now, we can rewrite our divisor as x minus 1 times x plus 1. That means we can write our divisor as product of linear factors. These are linear factors. That means the factor is the standard form is ax plus b. Then we have already mentioned that this is a linear polynomial. This is a linear polynomial. Now, our whole our whole divisor can be written as multiplication of linear factors. Okay, now this is very important point. Now, if we can rewrite our divisor as the product of linear factors, only there are only linear factors. If our divisor can be written into a multiplication of linear factors, then without using quotient, we can solve problems. We can solve questions. That means this is a very important point. If we can factorize any device as linear factors, then without using quotient, we can solve question. That means here without using this quotient, we can solve this question. Okay. Now let's rewrite x square minus 1 as x minus 1 times x plus 1. Then we can write this as px cube plus qx square minus 5x plus 1 is equal to x minus 1 x plus 1 qx plus minus 3x plus 4. Now here we want to find two variables, two unknown variables. They are p and q. That means there are two unknown variables. There are two unknown variables. That means we need we need two equations. Two equations to get their values. Get the values. That means the number of unknowns are need to be equal to number of coefficients. Okay. Now there are two linear factors in our quotient. So in our divisor. If this is equal to 0, then the whole term vanishes. That means we no need to find our qx. Let me repeat. If we substitute x equal 1, if we give x equal 1, then on our right hand side, on our left hand side, we get p times 1 cube plus q times 1 square minus 5 times 1 plus 1 equal to, on the right hand side we get 1 minus 1 times 1 plus 1 q1 minus 3 plus 4. Here there is also x. Then we need to substitute x equal 1. Now if we substitute x equal 1, this term becomes 0. That means the whole term vanishes to whole term becomes 0. That means in here we need to find the value of q1. That means we need to find the qx. That means quotient, because it vanishes when we plug x equal 1. This is very important theory for solving polynomials. That means on our left hand side we get p plus q minus 5 plus 1, and on the right hand side we get from here 0 minus 3 plus 4 means plus 1. That means we get p plus q is equal to 5. This is our equation 1. Likewise, now we can see if we plug x equal minus 1, the second factor also will become 0. That means the whole term will cancel out. Then if we plug x equal minus 1, then on the left hand side we get p times minus 1 whole cube plus q times minus 1 square minus 5 times minus 1 plus 1 equal to, here this term is vanishes to 0, and plus minus 3 times minus 1 plus 4. Here minus 1 to the power 3 is minus 1. That because an odd power of a negative number should be always negative. That means here we get minus p, and here we get plus q. Minus 1 times minus 1 is plus 1. Here minus 5 times minus 1 we get plus 5, and here they are actually meaning 1. On the left hand side, minus 3 times minus 1 is 3 plus 4. That means minus p plus q plus 6 is equal to 7. That means minus p plus q is equal to 1. This is our second equation. From the first and second equation, we can find the values of p and q. If we add first equation and second equation, we get p will cancel out 10. On the left hand side, we get 2q equal to 5 plus 1. That means 2q is equal to 6. That means q equal to 3. If we plug this value to equation 1, we get p plus q equal to 5 That means P equal to 5 minus Q. That means 5 minus 3 is equal to, then our P value is 2. Our P value is 2 and our Q value is 3. Okay, now I will give around 2 minutes to write down those things. Okay. Now I am going to solve the second question. Here, here we are given a polynomial called fx. Here nothing mentioned about the fx function, but they have mentioned that it is divided by x minus a times x minus b, and we need to find the remainder. Okay. According to division algorithm, we can write this as fx, our dividend, is equal to x minus a times x minus b times our quotient plus our remainder. Here, our divisor, this is our divisor. Here, degree of divisor is 2. That means our remainder, the degree of our remainder should be 1. Remainder, the highest degree for remainder should be 1. That means remainder should be, the standard form of the remainder should be ax plus b. Here a and b are already taken, so we put px plus q. This is standard form for degree 1 polynomial. Since a and b are already allocated, we use p and q. Okay, that means according to division algorithm, we can write fx is equal to x minus a times x minus b times qx plus px plus q. Okay, now they have mentioned that we need to prove the remainder. That means we need to find the value for p and q. So here they have not mentioned anything about the quotient. Now our device also fully factorized to the linear factors. That means without using qx, that means without using quotient, we can solve this question because our device is fully factorized into the linear factors. Now this bracket will become 0 if x equal to a, and this become 0 if x equal to b. That means we need to plug x equal a and x equal b to both sides. Then let's start to solve the question. Let's plug x equal to a into both sides. Then in our left hand side we will get fa. On the right hand side, from here we will get 0, because if we plug a minus a becomes 0. Then the whole term will become 0. 0 plus, from here we get p times a plus q. That means we can take fa is equal to p times a plus q. This is our first equation. Okay. Likewise, we can substitute x equal b, because if we substitute x equal b, this whole term will vanishes and give the value of 0. Then on left hand side we will get fb is equal to 0 plus pb plus q. That means fb is equal to p times b plus q. This is our second equation. From those two equations, we need to find the values of p and q. values of P and Q. Now, if we subtract our first equation with second equation, if we subtract the second equation from the first, then P term will cancel out and we can easily find the value of P. On the left hand side, we will get FA minus FB. On the left hand side, we will get FA minus FB. On the right hand side, we will get PA minus PB. Those Q terms will cancel out. That means here on the right hand side, we will get P times A minus B. That means FA minus FB. Okay. Now we can write P is equal to FA minus FB over A minus B. Okay. Here we divide by A minus B. Here this is A minus B in our denominator. So we need to write that A minus B cannot be equal to 0 because we already know this from our first lessons in combined mathematics. So in mathematics, the denominator cannot be equal to 0. That means here A cannot be equal to B. Now this is our P value. Let's get it as equation 3. Now we have already found the value of P. Now we need to find the value of Q because we need to finalize our answer with Px plus Q. Okay. Now from equation 1, we have FA is equal to P times A plus Q. FA is equal to P times A plus Q. That means Q is equal to FA minus P times A. Here P times A. P times A. That means FA is PQ is equal to FA minus. Now P is from 3 FA minus FB over A minus B. This is our value of P times A. Okay. Now we can get the common denominator. Q is equal to common denominator is A minus B. Then FA need to multiply with A minus B. Here we can simplify this bracket. Then we will get minus A times FA plus A times FB because there is a minus sign. Then this also multiply with these two terms. Okay, now from here we can simplify this bracket also. From that we will get A times FA minus B times FA minus A times FA plus A times FB over A minus B. Then these two terms will cancel out and we will get for the value for Q is equal to A times FB minus B times FA over A minus B. This is the value for Q. This is value for Q. Now our remainder should be Px plus Q. Px plus Q. This is our remainder, Px plus Q. Okay, now our final answer should be like this. Okay, let me copy this answer. This should be our final answer. This should be our final answer. Now, what we have was px plus q. Px plus q. The value of p is fa minus fb, fa minus fb over a minus b. This is the value of p. That means our remainder is this times x plus q. Our q value is, this is our q value, a times fb minus b times fa over a minus b. Okay. Now here fa is in one place and here our fb is in another place. That means we need to group fa into one group and we need to group fb into other group. Okay. Also here our common denominator is a minus b. That means we can get our common denominator. And then we need to keep fa in one group and fb in other group. That means we need to get fa into one group and get all the terms related to fa. Here we will get fa into x. That means here x term will need to be in here. And here also we have a term fa. That means from this term also need to become the member of this group. That means here minus b will come. That means from those two this will get, and from this term we will get minus b. Now in the middle sign need to be minus. Now we need to put minus sign and get the fb value because fb is the member of the another second group. Now from here we will get, from here if we multiply with x we will get minus fb times x. Then here x should be here and here we will get a times fb. Since it is plus a times fb we need to put minus a because if we multiply minus fb with minus a we will get plus a times fb. Then this is the final answer for the remainder. Then our remainder should be fa times x minus b minus fb times x minus a over a minus b. This is the final answer. Okay. I will give another 2 minutes to write down those things. Okay. Start to write from here. I will give 2 minutes to write down those. Write down remainder theorem. Remainder theorem. Remainder theorem. Under that, write down when a polynomial when a polynomial fx is divided by fx is divided by x minus a the remainder is the remainder is fa. fa, where a belongs to real numbers, where a belong to real numbers. Okay, this is the new theorem we are going to learn. Under polynomial, first we learn about lone division. First we learn about lone division. From lone division, we have found our quotient, and remainder. Also, the degree of here, the degree of divisor. The degree of divisor can be any number, can be any positive number, any positive number, positive integer. That means from lone division, if we divide some function by x minus a, then we can find the quotient and remainder. Also, if we divide it by like a quadratic polynomial, that means ax square bx plus c. From here also we can find quotient and remainder. Or if we divide by a cubic polynomial, that means ax cube plus bx square plus cx plus d. From there also we can find quotient and remainder under lone division. That means we can, if we divide by any divisor, we can find the quotient and remainder. We have already learned about this. Also, after that, we have learned about division algorithm. Division algorithm. From there also, we have found our quotient. We have found our quotient and remainder. Also, in here also, the degree of divisor can be any positive integer. Divisor can be any positive integer. That means from here also we can divide by x minus a and found our quotient and remainder. Or if we divide by quadratic polynomials, then also we can find quotient and remainder. Also, if we divide by a cubic polynomial or any other higher degree polynomial, we can still find our quotient and remainder. Okay. Please write down those things. This is what we have already learned. Under polynomials, we have learned lone division and division algorithm. From those two theorems, we can find any quotient and any remainder. That means the degree of divisor can be any positive integer. Please write down those things first, then I will explain about the remainder theorem. Okay. Now we are going to learn about remainder theorem. In here, in our remainder theorem, they have said that if our polynomial fx is divided by x minus a, if our polynomial fx is divided by f minus a, then the remainder then the remainder is equal to fa. The remainder is equal to F A. This is the shortest form of remainder theorem. This is the shortest form of remainder theorem. That means if we have a function polynomial fx, if we divide by it x minus a, then the remainder should be fa. Okay. Here, what we can gain is, here we divide by x minus a. We divide by x minus a. That means here in the remainder theorem, they only mention about a linear polynomial. Linear polynomial. That means our divisor should be, our device should be a linear polynomial. Linear polynomial. Because in remainder theorem, they have mentioned only about dividing x minus a. That means a form of linear polynomial. This is the very important thing under the remainder theorem. That means the degree of divisor need to be equal to 1. This is one of main point in remainder theorem. Okay. Now, as the naming here, they have named this theorem as remainder theorem. Remainder theorem. Remainder theorem. That because of here we only can find the remainder. We can only find the remainder. We can only find the remainder. But under the lone division and division algorithm, we can find remainder and quotient also. Also, we can use that for any degree of divisors. But here, under remainder theorem, we only can find the remainder, and our device should be, the degree of the device should be only 1. Need to be equal to 1. Those are major drawbacks under the remainder theorem. But if someone wants remainder and someone the divisor is degree 1, then this is one of the easiest way to find the remainder when we divide polynomials by degree 1 divisors. Okay. Now, the main theory behind the behind the remainder theorem is, now we are divide by x minus a. We are divide by x minus a. Okay. Now, our dividend. Our dividend is fx. Our dividend is fx. Now, our divisor is x minus a. Then they have mentioned that our remainder is f a. F a. That means our divisor is x minus a. Okay. We first equal this divisor to 0. We set the divisor to 0. Then we find the value of the variable f. Then x is equal to a. That means we need to find the value of variable when the divisor becomes 0. That means x equal to 0. Then we substitute that value for our dividend. Then we substitute that value for dividend. That means f, we need to substitute x as a. Then we get our remainder. Very easy one. Remainder. Let me repeat first. We set our divisor to 0. That means we equal this to 0 and find the value for our variable. That means x equal a. Then we plug this value to our dividend. Very easy method. Okay. Let me repeat some examples for you all. Let's say we have a function called fx, and we are going to divide it by x minus 2. X minus 2. That now we need to find our remainder. We need to find our remainder. The way to find remainder is we set our x minus 2 to 0 and find the value x equal to 2. Find the value for 2. That means we set our divisor to 0 and find the value for variable. Then we plug that value to our dividend, our function. That means remainder is equal to f2. This is our remainder. Okay. That means we set x minus 2 to 0 and find the value of x2. Then remainder is f2. Okay, first we write down those things. Okay, right to start writing from here. The remainder theorem is very simple one and most used in our A-level papers. That means we are mostly use this remainder theorem because it is easy to find remainders if we divide by linear divisors. Okay, first write down those things. Okay. Now I will give some examples. Let's say we have a function gx. Gx is divided by x plus 3. Divided by x plus 3. Then we need to find the remainder. The step is first we set our divisor x plus 3 equal to 0. From there we get our x value. That means x plus 3 equal to 0. That means x is equal to minus 3. That means x is equal to minus 3. Then we plug this value to our dividend. That means our function. Then the remainder should be equal to g minus 3. G minus 3. This is very easy one. That means we can write this as if gx is divided by x plus 3. If gx is divided by x plus 3, the remainder is simply g minus 3. That means we plug our divisor to 0 and find the value for x. Then we substitute that value for our dividend. Okay. Now I will give another example. Let's say we have a function px. We need to divide this from by x plus 7 over 2. X plus 7 over 2. Now, first thing we need to set our divisor to 0. X plus 7 over 2 to 0. And from there we can find x is equal to minus 7 over 2. Then our remainder should be equal to p. For x value we need to substitute minus 7 over 2. The value we are taken from setting our divisor to 0. Then from here also we can write if px is divided by x plus 7 over 2, the remainder is p minus 7 over 2. P minus 7 over 2. Okay. First, write down those examples. I will give another 1 minute to write down those things. After writing down those, write this one also. When the divisor is set to 0, the value of x obtained the value of x obtained is substitute into the polynomial. That means into dividend to find the remainder. After writing the above two example, write down this also. Now I am going to solve some example related to remainder theorem. Let me give example 1. Write down with me. Find remainder when fx equal to x square plus 3x plus 4. Find the remainder when fx equal to x square plus 3x plus 4 is divided by x minus 2. X minus 2 is divided by x minus 2. Okay. Here they ask from us only about the remainder. And here our divisor is x minus 2. That means divisor is a linear polynomial and they want only remainder. Then that means we can use remainder theorem. Okay. According to remainder theorem, we need to set our divisor to 0. That means x minus 2 to 0. From there, we get x equal to. After that, our remainder should be, we need to plug this value for our function. That means our dividend. That means our remainder should be f2. Now we already know about fx is equal to x square plus 3x plus 4. That means f2 is equal to 2 square plus 3 times 2 plus 4. That means F2, we plug x equal to 2 here. That means the remainder should be 2 square is 4 plus 3 times 2 means 6 plus 4. That means remainder should be 40. Okay. Now I will explain another example. Let's say we need to find the remainder when gx and gx equal to x cube plus 2x square plus 3x minus 1 is divided by x minus 1. X minus 1. Here they ask from only remainder, and our divisor is also a linear polynomial. That means we can use remainder theorem. Now, according to remainder theorem, we need to set our divisor to 0. From there, we get x equal 1. Then our remainder should be equal to g. Our dividend or our function is gx. That means we need to plug this value to gx. That means we need to find the value of g1. That means 1 cube plus 2 times 1 square plus 3 times 1 minus 1. That means 1 plus 2 plus 3 minus 1. From here, we can get our remainder as 2 plus 3 is 5. This 1 and this minus 1 is cancelled out. That means remainder is 5. Okay. Now, please write down those two examples. I will give 1 minute to write down those things. After that, write down those important things, these two things. Now, for using remainder theorem, the degree of divisor should be 1. The degree of divisor should be 1. That means only linear divisors can be used in remainder theorem. The other important thing is we can only find remainders under remainder theorem. We can only find remainders. Please write down those important two things also. Okay. Okay. Now, someone can say remainder theorem in another way. Let's say version 2. Both can be used for our calculations. That means someone can say when a polynomial, okay, write down with me this also, remainder theorem, another way for stating remainder theorem. Let's say, write down with me when a polynomial fx, when a polynomial fx is divided by ax plus b, when a polynomial fx is divided by ax plus b, the remainder is f minus b over a. This is same as the previous one. That means what we are doing is we set our ax plus b to 0. Our divisor 0, divisor to 0, and find the value. That means x is equal to minus b over a. Then we plug that value for our function. This is same as previous remainder theorem. Both are representing the same theory. Write down this also. On some books, they have mentioned remainder theorem as this. Many books state remainder theorem as our previous one. That means this one. We are mainly use this one. Both are representing the same theory. Or you can use this one. Write down this one also. This is the same content as the previous one. Okay. Now I am going to show the proof of this remainder theorem. The proof of this remainder theorem. Okay. According to division algorithm, according to according to according to division algorithm, we can write a dividend. Say mention that dividend is equal to divisor times quotient plus remainder. That means if we say our dividend is fx, then divisor is dx times our quotient is qx plus our remainder is rx. Okay, from here, from this theorem, we can write fx is equal to, now our divisor is x minus a. In the remainder, our divisor is x minus a times qx. Now we already know if we divide by degree 1 polynomial, then the remainder should be degree 0 polynomial. That means a constant term. This should be constant term. That means we can write for x minus a, for x minus a, that means the degree is 1. The degree is 1. The degree is 1. So the degree of the degree of remainder, that means the highest degree. The highest degree of the remainder is 1 minus 1. That means 1 is the degree of the divisor. Then the degree of remainder should be 1 less than the degree of the divisor. That means 0. Which is a constant. Term. So let's call it as capital R. Okay. Now we have write this according to our division algorithm. That means fx equal to x minus a times qx plus r. Now we need to find the value for r. Now from our first example from the previous day homework, if we don't want to find quotient, then we need to plug a value that vanishes the quotient. That means if we plug x equal a to both sides, then this term will cancel out and become 0. That means fa is equal to a minus a times qa plus r. Here r is a constant term according to this. R is constant term. That means fa is equal to here 0. This means 0 times qa plus r. Here 0 times anything is 0. That means fa is equal to r. Then what is the r? Now r is our remainder. Then remainder should be equal to fa. Very simple proof. This is what is stated under the remainder theorem. Very easy theorem. Okay. Now write down those things. This is very easy theorem and very easy to solve questions under the remainder theorem. Okay. Write down those things. Now I will explain another example, and after that I will give some questions to solve by you. Let's say this is some example number 3. Find the remainder when px is equal to x square plus 3x minus 5 is divided by x plus 2. It's divided by x plus 2. Okay. Here they ask only from about the remainder, and we are divided by x plus 2. That means our divisor is a linear polynomial. Then we can use remainder theorem. That means the divisor, we need to set the divisor to equal to 0. Then we will get x minus 2. X equal to minus 2. Then we need to substitute that value for our dividend, our function. That means x minus 2 need to be replaced here. Then our remainder is p minus 2. That means we need to substitute minus 2 into x. Minus 2 whole square plus 3 times minus 2 minus 5. That means 4 minus 6 minus 5. Then we will get our remainder as minus 7. Okay. First write down those things, and here I will give another set of question. Please try this by your own and send me the answers. First question is, find the remainder while I am writing this question. Please write down example tree. Just write down the example tree. Then I will scroll up, down and write other two questions. Write down these three questions and do by your own and send me the answers for these three questions. Okay. Now I will start to solve the first question. Here they ask only for remainder. Then also the divisor is x plus 1. That means a linear divisor. That means we can use remainder theorem. According to remainder theorem, our divisor is x plus 1. Then we set our divisor to 0. From there, we obtain x equal minus 1. Then our remainder should be, then our remainder should be g minus 1. That means minus 1 to the power 2027 plus 5 times minus 1 minus 6. That means we already know minus 1, the power, if the power of the negative number is odd, then the final value should be a negative value. That means minus 1, minus 5, minus 6. That means the final answer, the remainder is minus 2. Okay, now in our second question, still they are asking only for remainder. We are divide by a linear polynomial. That means we need to set our divisor equal to 0. From there, we can obtain x equal minus half. Then our remainder should be equal to h. We substitute x equal minus half. That means remainder should be equal to h minus half. That means we need to find the value of h minus half. That means minus half to the power 4 plus 4 times minus half to the power 2 plus 2 times minus half plus 1. From here we get 1 over 16. From here we get 4 times 1 over 4. From here we get minus 1. From here we get plus 1. This will become 0. That means our final answer will be equal to 1 over 16 plus here 4 is cancelled out with this 4 and give 1. That means final answer is 16 here. And denominator we get 16. On numerator we get 1 plus 16. That means final answer would be equal to 17 over 60. Okay, this is the answer for the second question. Now I will solve the third question also. Here they have mentioned that remainder is equal to 100. Remainder is equal to 100. Now from remainder theorem, we already know if we divide by x minus 2, then we can find the remainder. Now our fx is equal to x to the power 4 plus 5x cube plus 7x plus k. We are divided by x minus 2. That means our remainder can be found by using setting x minus 2 equal to 0. That means x equal to 2. Then our remainder should be equal to f2. That means our remainder is equal to f2. That means 2 to the power 4 plus 5 times 2 to the power 3 plus 7 times 2 plus k. From here we get 16. 2 to the power 4 means 16 plus 5 times 2 to the power 3 means 8 plus 7 into 2 means 14 plus k. From here we get 16 plus 5. 5 times 8 means 40 plus 14 plus k. Okay. From 16 plus 14 means 30. That means f2 is equal to, from those two numbers we get 30. Then we need to add 40. 30 plus 40 means 70. Then we will get 70 plus k as our remainder. But they have mentioned that this remainder should be equal to 100. This remainder should be equal to 100. That means 70 plus k need to be equal to 100. From this equation, we can get k is equal to 100 minus 70. That means 30. Then the final value of k is 30. Okay. Now I will give around 2 minutes to write down those things. Try to solve this three question and send me the answers. I hope you already wrote these three questions. Now I am going to explain the previous questions for answers for the previous questions. In the first question, they have mentioned that the remainders are equal to each other. That means we need to find the remainder of fx when we divide it by x minus 2 and the remainder from the gx when we divide it by it x minus 1. That means for fx, we divide by x minus 2. Then that means we want we set x minus 2 to 0, that means x equal to 2. That means remainder is equal to f2. On the other side, they have mentioned that gx, when gx is divided by x minus 1, that means when we set x minus 1 into 0, that means x equal to 1. That means remainder should be equal to g1. That means they have mentioned that remainders are equal. That means f2 is equal to g1. f2 is equal to g1. Now f2 means a times 2 to the power 3 times 2 to the power 2 times 3 times 2 plus 40. This is equal to g1. g1 means 1 whole square plus a times 1 plus 2. Now we need to simplify this and find the value for a. Here 8a plus 4 plus 6 plus 14 is equal to 1 plus a plus 2. Here 14 plus 6 means 20. 20 plus 4 means 24. That means 8a plus 24 is equal to 1 plus 2 means 3 plus a. That means we can bring left hand side of a and move 24 to right hand side. That means 8a minus a is equal to 3 minus 24. 7a is equal to minus 21. That means a is equal to minus 3. Okay. This is the answer for the first question. Please write down this and I will solve the second question. Okay. Now I will solve the second question. Here they have mentioned that px, that means x to the power 3 minus 7x square minus 12x plus 1 is divided by x minus 2. And also they have mentioned that qx, which is equal to x to the power 5, x to the power 5 plus 10 times x to the power 4 plus k is divided by also x minus 2. They have mentioned that two remainders, the summation of two remainders are equal to, that means two summations are equal to 100. Okay. From px, we set the divisor equal to 0. That means x equal to 2. That means the remainder from px is, that means remainder from px equal to p2, and the remainder from qx is equal to q2. That means they have mentioned that those two remainders, the summation of those two remainders are equal to 100. Now we need to find the value for k using this equation. Okay, now from p2 we can get 2 cube minus 7 times 2 square minus 12 times 2 plus 1. Plus from q2 we get 2 to the power 5 plus 10 times 2 to the power 4 plus k. Those two summations are equal to 100. The sum of those two is equal to 100. That means from here, from left hand side, we get 2 to the power 3 minus 7 times 2 to the power 2 minus 12 times 2 plus 1 plus 2 to the power 5 plus 10 times 2 to the power 4 minus 100, so equal to minus k. Simply I move right hand side k and move left hand side to 100, because on the then in our left hand side all are numbers and in our right hand side only the variable. Now we need to simplify this. Okay. Now here we have from this term and 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 from this term. We can factor out 2 to the power 2. We can factor out 2 to the power 2. That means 2 to the power, we can factor out those from those terms. Then from the first term, 2 is remaining. From the second term, minus 7 is remaining. From third term, minus 6 is remaining. From this term, 8 is remaining. From this term, 10 times 4 is remaining. From this term, minus 25 is remaining. Then here, apart from that, plus 1 is remaining. This is equal to minus k. Now we need to simplify this. That means 4 times, here 10 times 14 means 40. Then from 40 minus 25, we will get 50. From these two terms, we will get 50. Then from 2 plus 8 means 10. 2 plus 8 means 10. Then here from these two, we can get 10. Minus 7 minus 6 means minus 30. Then the final terms are 10 minus 13 plus 50 plus 1 equal to k minus k. From here, 15 minus 13 means 2. Then 10 plus 2 is remain. That means on the bracket, inside the bracket, 12 is remaining. Then the final answer for k is 4 times 12 plus 1 is equal to minus k. That means k is equal to minus 49. This is the final answer for the k. Okay. Now start to write down this. Now I am going to solve the first question from the second set of questions. Okay. Here they have mentioned that our fx, that means equal to x cube plus px square plus 2x plus p, is divided by x minus 1, and gx x square plus 3x minus 1 is divided by x plus 1. Okay. Now they have mentioned that, okay, first we try to find remainders from fx. The remainder is here. This is our divisor. We need to set it to 0. That means x equal 1. Then the remainder is f1. From gx, similarly, we can obtain our remainder as g minus 1, because we need to set this value to this divisor to 0. Then that means x equal minus 1. Now they have mentioned that fx is divided, the remainder when fx is divided by x minus 1 is 7, less than twice the remainder of gx. That means they have mentioned that the remainder of f1, the remainder of fx, that means f1, is equal to twice 2 times g minus 1, that is remainder from gx, minus 7. That means less than 7, twice of this. That means 2 times the remainder minus 7. Now we need to plug f1 here and g minus 1 here and get the answer. Okay. f1 means 1 cube plus p times 1 square plus 2 times 1 plus p equal twice. G minus 1 means minus 1 whole square plus 3 times minus 1 minus 1 minus 7. From left hand side we will get 1 plus 2 means 3 plus 2p. On the right hand side we get 2 times minus 1 square means 1, minus 1 and minus 1 cancel out and give 0. That means on the bracket remaining minus 3, minus 7. Then 2p is equal to, here 2 times minus 3 means minus 6, minus 7. Then we can move 3 to right hand side. Then it becomes minus 3. Then 2p is equal to minus 16. That means p is equal to minus 8. This is the final answer. Okay, I will give another 1 minute to write down this. Now I am going to explain the second question. Here they have mentioned that fx is equal to, second question, they have mentioned that fx is equal to x to the power 4 plus ax cube plus bx square plus cx plus 1. And they have mentioned that when it is divided by x minus 1, the remainder is x. When it is divided by x plus 1, the remainder is 10. When it is divided by x minus 2, remainder is 31. That means when we divided by x minus 1, we set this to 0. That means x equal 1. Then remainder should be f 1. That means they have mentioned that f1 is equal to 6. Likewise, they have mentioned that f minus 1. That means this is our second divisor. We set that divisor to 0. Then we will get x equal minus 1. That means f minus 1 equal to 10. Also, they have mentioned that f2 is equal to 31. That means we set x minus 2 to 0. From there, we will get x equal to, then we plug that value to 0. Then now we need to find three unknown terms, A, B, and C. For those three unknowns, we need three equations. Now, f1 means 1 to the power 4 plus A times 1 to the power 3 plus B times 1 to the power 2 plus C times 1 plus 5 is equal to 6. From here, 1 plus A plus B plus C plus 5 is equal to 6. From 5 and 1, we will get 6. That means A plus B plus C need to be equal to 6 minus 6. That means 0. Then our first equation is A plus B plus C is equal to 0. From the second question, we will get f minus 1 equal to 10. That means minus 1 to the power 4 plus A times minus 1 to the power 3 plus B times minus 1 to the power 2 plus C times minus 1 plus 5 equal to 10. From here, we will get 1. From here, we will get minus A. Minus C. From here, we will get plus B. From here, we will get minus C plus 5 equal to 10. That means minus A plus B minus C equal to 10 minus 1. We bring 1 to left hand side, right hand side, 5 also on the right hand side. That means minus A plus B minus C is equal to 4. This is our second equation. Also, we know that f2 should be equal to 31. That means 2 to the power 4 plus A times 2 to the power 3 plus B times 2 to the power 2 plus C times 2 plus 5 need to be equal to 31. 2 to the power 4 means 60 plus 8A plus 4B plus 2C plus 5 is equal to 31. 16 plus 5 means 21. That means 8A plus 4B plus 2C is equal to 31 minus 21. That means 10. Then we can divide both sides by 2. That means 4A plus 2B plus C need to be equal to 5. This is our third equation. Now we have three equations. First one is A plus B plus C equal to 0. The second one is minus A plus B minus C equal to 4. The third one is 4A plus 2B plus C equal to 5. Okay. This is our first equation, this is our second equation, and this is our third equation. If we add first and second equation, this A term and C term will cancel out, and left hand side we will get 2B. On the right hand side we will get 4. That means B equal to 2. Okay. Now we need to find A and C. A and C. Okay. If we substitute this B value for the equation 1, if we substitute with B is equal to equation 1, we will get A plus 2 plus c equal to 0. That means a plus c equal to 0. This is 1 dash. If we substitute our b value to equation 3, we will get 4a plus 2 times 2 plus c equal to 5. That means 4a plus c equal to 5 minus 4 equal to 1. This is our second dash equation. From first dash and second dash, if we subtract 2 dash from 1 dash, we will get c will cancel out and we will get 3a is equal to, so here we have 4a plus 2b, here c. Here in the second equation, a plus c is not equal to 0. Here there is 2. We need to bring these 2 into right hand side. That means a minus 2 is minus 2. Okay. Then on the left hand side, we will get 4a minus a. C will cancel out. On the right hand side, we will get 1 minus minus 2. That means 3a is equal to 3. A is equal to 1. From first equation, we have a plus c equal to 2. A plus c equal to minus 2. From there, we can obtain c is equal to minus 2 minus a. That means minus 2 minus 1. Then c is equal to minus 3. Then a value is 1, b value is 2, c value is minus 3. Okay, I will give around 1 minute to write down these things.